Well, the expression we get here is going to be, just a little complicated, but it's going to be K times little q times big Q. And I shouldn't, I'll just put that over 1. I should have done that as a factor. And then we're going to have to multiply that by what we get for this vector and what we get for this vector. And then we got to collect our I and j terms, right? So our I term is just going to be x plus L over 2 divided by quantity x plus L over 2 squared plus y squared raised to the 3/2, right? And then it's going to be plus, well, I didn't want to put the I there. Not sure what I might have wanted to do. But whatever I did, better if I don't put the I there, because then we're going to get the analogous term here, right? And then that'll be times the I vector. And then we're going to have plus the analogous term times the j vector. It'll differ from what we have here, and we'd have to have a 3/2 power here. It'll differ from what we have here only in that we have a y in each numerator, right? But it's the same in both cases, right? So it's going to be just 2y. No, I'm sorry, it's not going to be 2y. It's going to be, y over this plus y over this, right? Or y times the reciprocal of this plus the reciprocal of this. Now, since we would then tend to do some simplification, maybe with common denominators, and then some approximations, depending on what we want to find, we might then really well want to write this plus y times 1 over x plus L over 2 squared plus y squared plus 1 over x minus L over 2 squared plus y squared. And I'm writing that small because I didn't leave myself enough room. Okay? And then we've got to close some parentheses. Okay? So I don't have room to write out. There's just one set of parentheses that needs closed, so I can kind of indicate that. And here where I've got the plus y, kind of out of order, but all right, plus j times this, right? Okay, well, that's kind of a big expression. You hope you don't have to do too much with it, but you might well. And also we have 3/2 powers on these things, right? And I don't have room for 3/2 there, but you understand what should go there, right? Okay, well, I'll write it out correctly when I write it out for the electric field. What do we have to do to get the electric field?
We have to take this force that we just got and multiply it by
Okay, what's the
our
definition?
charge, right?
Yep. What now?
We have to take our force that we got, multiply it by our charge, right?
No.
No?
No, but you're close. What is the definition of
Oh,
electric field?
it's force per unit
force per
charge.
unit.
Oh, so
Yes,
it's
you
dividing.
said it.
Yeah, dividing, okay.
Okay,
I said
and then you said multiply, but
Yeah.
I could tell you were thinking in the right way, okay?
Oh, yeah,
It's
So,
force, yeah, it's dividing.
it's
'cause
just-
per unit, so yeah, I'm done. Yeah.
F over little q, it's the force per unit charge at this point.
Right.
You could calculate it for any charge you wanted to put at that point, but just call the dang thing q, right?
Right.
And then you can write out what this is, and I'll leave myself enough room, or attempt to leave myself enough room. And we're just going to get K times big Q, right? Times,
Times all that.
yeah, well, I'm gonna risk everything by doing a little bit more simplification, okay? We know we're gonna have x over this plus x over this, right?
Right.
Okay? So I'm gonna actually use just a symbol for this. I'm just gonna call it beta for this denominator. Well, for this expression, this plus this, okay? So I'm gonna say it's, okay, beta x plus gamma. I plus beta yj. Now this beta and gamma is not standard notation, okay? But beta and gamma don't really interfere with any of the standard notations that we use for basic electric fields and Coulomb's law, where beta equals the quantity that I wrote here. So it's 1 over x plus L over 2 squared plus y squared to the 3/2 plus 1 over x minus L over 2 plus y squared to the 3/2. Again, just isn't enough space to write it well, but it's very clear that we're just doing 1 over this plus 1 over this, right? And what's gamma? It's the same thing, but with a minus here, isn't it? So that gamma equals this minus this. Now, we want you to write the whole thing out, okay? And then we see that, first of all, this has a pretty simple expression. And if we were going to do a lot more with this field, it would be nice to have these two expressions, right? And if we're going to do an integral of this thing, okay? Yeah, standard integration technique would take care of integrals here, okay? An integral from xy to some other point. Or if we want to do certain other things, it might be handy to have this compact notation and then have a notation for maybe the simplification of this, a simplification of this, or if no simplification, at least a derivative of this and a derivative of this, okay? But there we have it. And then we can ask questions like, okay, what if x equals 0? This simplifies considerably if x equals 0, doesn't it? I left my square off here. The gamma term actually becomes 0, right? And both the beta and gamma terms should end up being 0 if x equals 0. Okay?
Is that good then? Because that would be x is 0.
Yeah, for some reason this doesn't look like that's going to happen. I mean, you have a plus here and a minus here, but you're adding them, right?
Yeah.
So And this is all very simple, so I don't know what could have possibly gone wrong, except that I wrote something down incorrectly. And I think maybe it comes out, okay, where I had the x minus L over 2I and the x plus L over 2I. This isn't just beta. I was a little bit careless here. Okay, well, yeah, it's beta times x. Something's wrong. I'm not going to do it in camera.